Welcome to The Explainer. Today, we're jumping right into one of the most universal, yet honestly deeply mysterious biological phenomena in human existence: dreaming. For as long as humans have slept, we've dreamt. From aboriginal cultures like the Esa Eja in the Peruvian Amazon, who actually view dreaming as the sacred mythological practice for gaining knowledge, all the way to modern neuroscientists who are mapping out the brain's neural networks, this nightly experience has just completely captivated us. But here's the wild part. Despite thousands of years of human thought, moving from ancient myths straight through to hard science, a complete 100% consensus on exactly why we dream, it still totally eludes us.
It all really begins with a fundamental question, and it's one that highlights a massive biological vulnerability. Think about it. Why do we spend hours every single night completely paralyzed, effectively hallucinating, and totally disconnected from the physical world? From an evolutionary standpoint, sleep, and especially the deeply immersive dreams that come with it, puts an organism at immense risk. You're just sitting there, completely vulnerable. Yet, it's conserved across species. This tells us that these nightly hallucinations, they aren't just random accidents. No, they are vital clues in an incredibly ancient biological detective story.
Okay, let's dive into this roadmap. First, we'll look at the ancient dream mystery. Second, Freud and hidden wishes. Third, simulating threats for survival. Fourth, random signals and memory. Fifth, the overfitted brain hypothesis. And finally, the ultimate dream synthesis.
Section 1. The Ancient Dream Mystery.
To truly understand where the science is today, we first need to appreciate how long humanity has been trying to demystify the inner workings of the sleeping mind. Looking at this timeline, you can see the inquiry goes way back. In the 4th century BCE, Aristotle actually noted the phenomenon of lucid dreaming. He basically wrote that sometimes there's something in our consciousness that declares, hey, what you're seeing right now is just a dream. Fast forward a bit to 1886, and a thinker named W. Robert posited a surprisingly modern idea to replace ancient myths. He suggested that dreams are a somatic process of excretion, basically a way for the brain to dump incomplete, unworked out thoughts that would otherwise pile up and completely smother our memories. And then, right at the tail end of the 19th century, in 1899, Sigmund Freud publishes his monumental work, The Interpretation of Dreams, which fundamentally changed how we viewed the sleeping mind.
Section 2. Freud and hidden wishes.
This brings us into the era of psychoanalysis. For the first time, dreams were systematically treated not just as physical excretion or a mental data dump, but as highly meaningful puzzles containing deep personal truths. Freud believed that all dreams are essentially forms of wish fulfillment. He argued that your unconscious forces are basically constructing a wish, but then there's this internal censorship agent that forcibly distorts it. So he split the dream into two distinct parts: the manifest content, which is the bizarre surface narrative you actually remember when you wake up, and the latent content, which is the true underlying meaning. During sleep, Freud argued, your unconscious takes multiple thoughts, condenses them into single images, and then displaces actual meanings onto seemingly harmless symbols just to sneak them past your mental censor. It's really an incredible theory of psychological disguise.
Now, what's really interesting about this is the stark collision depicted right here between clinical psychoanalysis and modern cognitive neurobiology. As the psychoanalyst Mark Blechner points out, this massive gap didn't actually exist when Freud started out. His early work was literally in animal neurology. But over the years, as neurobiologists got better tools and began precisely measuring brainwaves and firing neurons, they grew highly skeptical of Freud's symbolic, subjective interpretations, and that led to a massive collision and long estrangement between the two fields of study.
Section 3. Simulating threats for survival.
Let's step away from hidden desires for a second and move from the psychoanalyst couch straight into the harsh reality of human evolution. What if dreams are not about wishes at all, but about sheer survival? This brings us to the threat simulation theory, developed by Antti Revonsuo. This theory argues that the main biological function of dreaming is to simulate threatening events. Basically, think of it as an ancient virtual reality simulator. From an evolutionary perspective, your ancestors were the ones who were good dreamers. They used the safety of sleep to rehearse perceiving and escaping real-world threats. And the empirical evidence here is actually striking. Researchers have found that children who have unfortunately experienced severe real-world trauma from war, abuse, or natural disasters actually experience significantly more threats in their dreams. It's as if their early life trauma kicked their evolutionary dream simulator into overdrive just to keep them alive.
Section 4. Random signals and memory.
So how exactly does the physical brain generate these immersive simulators? Let's pivot to the brainstem to explore what modern technology reveals about the actual physical mechanics of sleep. Back in 1977, Harvard psychiatrists Alan Hobson and Robert McHarley proposed the activation synthesis hypothesis. They discovered that during REM sleep there is this periodic firing in the pons, which is a structure deep in the brainstem. These raw, essentially random signals travel all the way up to the higher levels of the brain. Now your cortex, which absolutely hates a vacuum of meaning, then frantically tries to synthesize these random, chaotic signals into a cohesive narrative. As Bleckner compares it, it's very much like the brain administering a Rorschach inkblot test to itself while we sleep. It generates a random image and essentially forces a story out of it.
Because the cortex is literally just synthesizing random offline activity, Hobson outlined 5 cardinal characteristics of the resulting dreams. You've got intense emotions, deeply illogical content, apparent sensory impressions that feel incredibly real in the moment, a totally uncritical acceptance of the bizarre events while they happen, and of course, a huge difficulty in remembering them once we wake up. The brain is quite literally making the best of a bad job, tying totally chaotic neural firing into some sort of conscious experience.
And this brilliantly illustrates the ultimate clash in dream theory. On one side, you have Freud's psychoanalytic view, where every single bizarre detail is a deeply meaningful condensed wish. On the flip side, you have the view of scientists like DNA co-discoverer Francis Crick and Graham Mitchison. They argued that dreams are entirely meaningless biological waste products. Much like a giant computer clearing out spurious data at night, they viewed dreaming as nothing more than nighttime house cleaning. So what's the deal here? Are dreams the ultimate truth, or are they literally just mental garbage?
Section 5. The overfitted brain hypothesis.
To find the middle ground, we introduced the climax of our explainer. We are now going to explore what artificial intelligence and deep learning can teach us about our own sleep. In the world of artificial neural networks, there's this really common, ubiquitous problem called overfitting. Overfitting happens when a neural network memorizes its daily training data too well. It becomes so perfectly tuned to the specific data it has seen that it totally fails to generalize to new, out-of-the-box situations. Researcher Eric Hole drew a pretty brilliant parallel here. The human brain, as an insanely complex neural network, faces this exact same danger. We go about our daily routines, learning and memorizing, and our brains run a real risk of becoming too rigid, too overfitted to our specific daily experiences.
Let's see how this builds into an entirely new biological function for sleep. AI programmers actually solve overfitting by injecting noise, basically corrupted or warped inputs into the network to forcefully make it stay flexible. Hole's overfitted brain hypothesis argues that dreams are our biological version of these noise injections. Think about that for a second. The bizarre, hallucinatory, highly illogical nature of dreams isn't a mistake, and it isn't a disguise. It is a vital feature. By purposefully warping our daily experiences with stochastic noise, our brains prevent overfitting. It keeps our minds generalized, incredibly creative, and fully ready for whatever weird curveball your waking life throws at you next.
Section 6. The Ultimate Dream Synthesis.
We've covered psychoanalysis, evolution, neurobiology, and artificial intelligence. Let's bring all these incredible theories together. So, the crucial point is that these perspectives don't necessarily cancel each other out, right? They actually form a complete 360-degree picture. Notice how each model in this matrix highlights a different primary driver. The psychoanalytic model highlights how we process emotional expression. The evolutionary model reveals how we rehearse for threats. The neurobiological model, which is heavily backed by MIT research, shows how that random brainstem firing drives memory consolidation, moving your daily experiences into long-term storage. And finally, the computational model explains how the bizarre nature of dreams prevents overfitting and drives cognitive generalization. Together, they explain a brain that is healing, practicing, storing, and optimizing itself, literally all at once.
Ultimately, as the MIT McGovern Institute beautifully puts it, even with absolutely everything science has uncovered about memory, creativity, and neural noise, the magical essence of this universal human experience remains untainted. Dreaming is just a profoundly complex biological and psychological masterpiece happening inside your head every single night. So as you get ready for bed tonight, I want to leave you with this provocative thought. As you drift off and those nightly hallucinations begin, what exactly will your mind be optimizing tonight?